Hi friends, today let's discuss about bonding in coordination compounds by using valence bond theory or VBT. So in this theory we are going to learn about how a coordinate bond is formed between central metal atom and the ligand. So that how the molecule is being formed. Not only that, through hybridization we are going to understand about the geometry, magnetic behavior and type of complexes. So in your lesson like coordination compounds, especially two types of compounds you are studying, the compounds with the coordination number 4 and the compounds with the coordination number 6. If the coordination number is 4, two types of hybridization are possible like sp3 or dsp2. If it is sp3, structure is tetrahedra. If it is dsp2, the geometry is square planar. And if the coordination number is 6, it can be sp3d2 or d2sp3, and in both the case the geometry will be octahedral only. So when you get a question, you have to understand first of all about the coordination number, and any of these geometry or any of these hybridization will be the answer for that. So from that we will be able to identify the magnetic behavior and type of complexes. Let's do some of the questions to understand more about this. First, CONH3 6 times 3 plus. First step is to calculate the oxidation state of the central metal atom. Let it be X. Ammonia is a neutral ligand, so that it will be 0 oxidation state. So X plus 0 is equal to plus 3. This is the normal way of finding the oxidation state only. So X is equal to plus 3. For that. Now we write the cobalt electronic configuration in the ground state. Because of electronic configuration like 27 is the atomic number, it is 3d7 4s2. So electronic configuration is actually easy to write. If it is 21, you write 3d1 4s2. Always 4s2 is there, and the number in the atomic number, the number comes in the ones place will be the number of electrons present in the 3d orbital. If it is 22, you write 3d2. This 2 comes from the atomic number ones place like this 4s2. So cobalt is 27, so 3d7 4s2. Now you write cobalt in the excited state configuration. Excited state means by losing 3 electron. Why? Because it has oxidation state of plus 3. So that 3 electrons to be lost in total, 2 from 4s and 1 from 3d will be losing. It results 3d6 is the configuration. So now we start doing the orbital diagram by using 3d6 configuration. So there are 3 steps. First step you write cobalt 3 plus orbital diagram. So 3D having 5 orbital 1, 2, 3, 4, 5, 6. This is 3D. After 3D 4s orbital is there but it is vacant. After 4s 4p is also there but it is vacant. So you must draw whether it is vacant or not, no issue. You must draw 4s and 4p orbital because we are just learning about the hybridization, so we need some hybrid orbitals. For that, the vacant orbitals are required. This is the first step. Second step, the central metal atom is combining with ammonia, or ammonia is approaching with the central metal atom. So because of the presence of ammonia, something will happen in the configuration of 3d orbital. For that, a small thing you have to study, that is, some ligands are called as strong ligands. Some ligands are called as weak ligand. So that strength of ligand is that is explaining by using crystal field theory only. That is by using crystal field stabilization energy and pairing energy comparison. So in coming video I'll be discussing about that. For the time being, I'll be giving the list of ligands which are acting as strong and weak. Normally ammonia, carbon monoxide, cyanide are acting as strong ligand. Weak ligands are water. All halogens like F minus, Cl minus, Br minus, I minus, all are weak only. So for the time being, you study the list of these ligands. So now ammonia is a strong ligand. Because of the strong or strength of that ligand, the electrons present in the 3d orbital will do pairing. So we have to do like this 1, 2, 3, 4, 5, 6. So that you are getting 2 empty d orbitals. 4s and 4p, same way you draw as empty. This is the second step. Now in the third step, before drawing the third step, you need to understand about the coordination number now. The coordination number is 6. Coordination number is number of donor atoms. There are 6 donor atoms in total. So if 6 is the donor atom or 6 is the coordination number, 6 will be the hybridized orbital. So that hybridized orbital you have to understand by looking into the vacant orbital. Here you see 2 orbitals from 3D, 1 orbital from 4s, 3 orbitals from 4p are vacant. The exact number of 6 orbitals are there. Exactly it is there. So that these 6 orbitals will hybridize to form hybridized orbital. And how to write the hybridization name is depending upon the number of orbits. Here D 2 orbitals are free, in S only 1 orbital, and in P 3 orbitals are free. So the name of the hybridization is D2sp3 hybridization, having 6 hybridized orbital. This is the second step. So second step we just found only two things, like whether the ligand is strong or not, accordingly pairing will be taking place or not. Second point I have talked about coordination number, accordingly empty orbitals you are calculating and finding the hybridization. Now in third step, the orbitals which are not participating in hybridization to be drawn separately. 1, 2, 3, 4, 5, 6 electrons are already there, and the orbitals which are participated in hybridization 6 in number. So 1, 2, 3, 4, 5, 6. Now it is empty, but each ammonia will be donating 2 electrons to cobalt. So we know that a coordination compound means there will be coordinate bond. Coordinate bonds are the bonds which are formed by donating a pair of electrons from a particular atom. So each ammonia will be donating 2 electrons to cobalt. So total 6 ammonia are there. So altogether 12 electrons are coming towards cobalt or sharing with the cobalt. As a result, 6 coordinate bonds are being formed. So here I have marked 12 electrons. These 12 electrons are coming from ammonia only. As a result, 6 coordinate bonds are formed between cobalt and ammonia. So the molecule is being formed. This is how the molecule is formed. Now finally, we can write the hybridization is D2sp3, and because of the D2sp3 hybridization, the molecular geometry is octahedral. That in the beginning I told you. Whether it is D2sp3 or sp3d2, structure is always octahedral. And magnetic behavior. In the last step, you see if any unpaired electrons are there or not. If no unpaired electrons, it is diamagnetic. All orbitals are there with a paired electron. So it is diamagnetic. And then type of complex. Type of complex means there are two types of hybridization if it is octahedral. D2sp3 and sp3d2. In D2sp3, d orbitals are participating from inner side. In sp3d2, outer d orbitals are participating. If inner d orbitals are participating, we have to call it as inner orbital complexes. Inner orbital complexes, which is also called a low spin complex. So low spin complexes are usually formed when a coordination compound in which there will be strong ligand. Because of the presence of strong ligand only electrons are being paired, so that inner d orbitals will be vacant. So low spin complexes is generally occurred in a coordination compound with a strong ligand. If it is sp3d2, that time you have to write outer d orbital or outer orbital complex or high spin complex. So this is the hybridization in CONH3 6 times 3 plus. So let's take another example, COF6 3 minus. First you find the oxidation state of the central metal atom X. For cobalt, fluorine is minus 6. Why? Because fluorine is minus 1 only. That minus 1 into 6 becomes minus 6, which is equal to minus 3. So X is equal to minus 3 plus 6 equal to plus 3. Same oxidation state. So we can repeat all the same step here also. Cobalt is 27, 3d7 4s2, same step. And by losing 3 electron, cobalt is in plus 3 oxidation state, so 3d6. So now 3 steps to be drawn. So I'm going to start with the first step. Cobalt 3 plus 3d6. So 5 orbitals, 1, 2, 3, 4, 5. 6. This is 3D, but I told you we need to draw 4s, which is empty, and 4p, that is also empty, to be drawn. Now in second step, fluorine will approach the central metal atom. So according to the strength of the ligand, something will happen. But fluorine, I gave the list of strong and weak ligand. Fluorine comes as the weak ligand. Because of weak ligand, there is no change in the configuration. The 3D orbital configuration in the first step and second step will be same only. We don't need to change, or we don't need to pair the electrons. So there is no change in the second step. Now we need to look into the coordination number. Coordination number is 6. But we don't have 6 empty orbital. 1, 2, 3, 4 only. We need 2 more. Those 2 more will to be taken from 4D. The D is outer D. So in the first step also you draw that D orbital. Now in the second step also drawing the D orbital. Now you take 1s, 3p and 2d. 1s, 3p and 2d. So the hybridization is sp3d2. This is how you have to draw the second step. And the last step is, I told you the orbitals which are not participating in hybridization, draw together. All these 5 3D orbitals are not participating. So we have to draw as it is. And now the sp3d2, 6 orbitals. 1, 2, 3, 4, 5, 6. And the remaining 3 orbitals are not participating. That is separately we are drawing. These 3 only, these 3. Got it? Now electrons. How the electrons are pairing? 6 fluorine atoms are there. Each fluorine will be donating 2 electrons to the central metal atom. As a result, 6 coordinate bonds are being formed between cobalt and fluorine, so the molecule is being formed. In the last 3 boxes, it's still empty, only no electrons. So the hybridization is sp3d2, geometry is octahedral geometry, and the magnetic behavior, you can see 4 unpaired electrons, so it's paramagnetic. And the type of the complex is outer orbital. Why? Because outer d orbitals are participating in this, or which is also called a high spin complex. So you can see here weak ligands are there in the complex, so it forms high spin complex. So these 2 examples are coming under coordination number 6, so you can practice more questions. Now I will take a compound with the coordination number 4, NaCN4 times 2 minus. First you calculate the oxidation state, let it be X. Cyanide is 1 minus, so total minus 4. X minus 4 is equal to minus 2. X is equal to plus 2. Nickel is plus 2. Nickel is 28. So the configuration is 3D8, 4s2. But it is plus 2 oxidation state, so 2 electrons will be losing. So nickel in the excited state configuration is 3D8. Now first step you draw the orbital diagram. 3D8. 5 orbitals with the 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. This is 3D. Then 4s, I told you, which we need to draw. Similarly 4p, the empty one to be drawn. Got it? Now second step. Second step, you write the complete molecular formula like NaCN4 times 2 minus. Now cyanide is approaching nickel, so that depending upon the strength of the ligand, pairing may or may not be taking place. Cyanide is a strong ligand, so pairing will be taking place. So the 8 electrons which are present in 3D orbital will be filling like this. 1, 2, 3, 4, 5, 6, 7, 8. So 1 d orbital will be vacant. 4s and 4p. Got it? Now you need to look into the coordination number, which is 4. So we need 4 empty orbital. We'll calculate 1, 2, 3, 4. So 4 empty orbitals already there. We don't need to take 4 d orbitals and all, and now you join. This d, this s and 2p. Means 1 d is there, 1 s is there and 2p are there. So dsp2. This is not participating in hybridization, the last p orbital. So dsp2 is the hybridization, and last step is NaCN4 times 2 minus the one which are not participating in hybridization together. It means out of 5 orbitals from 3D, you draw only 4 orbitals because one is participating. 1, 2, 3, 4, 5, 6, 7, 8, only 4. And now the remaining 4 hybridized orbital. 1, 2, 3, 4. And the last one which is not participating. This is only this. That is empty. Now to these unhybridized orbital. To these hybridized orbitals, electrons are donating from cyanide. One cyanide is giving 2 electrons. Like that, total 4 cyanide ions are there. Altogether 8 electrons are sharing with the nickel. It forms 4 coordinate bond. So hybridization is dsp2. Acid because of dsp2. The beginning I told you, if it is dsp2, the geometry will be square planar. So we can write the geometry here. Yeah, we can write the geometry here, which is square planar. And the magnetic behavior. There is no unpaired electron, so it's diamagnetic. And for coordination number 6-step complexes only, we need to write whether it is high spin or low spin, or outer d orbital or outer orbital complex or inner orbital complex. For this, coordination number is 4, so it's this cases it's not needed. Only these 3 steps are enough: hybridization, magnetic behavior, and geometry. And the last example, NiH2O4 times 2 plus. Nickel again 0. Water is 0, so nickel is X. So X plus 0 is equal to plus 2. Again nickel plus 2 oxidation state only. We'll repeat the same step, the previous step. Nickel plus 2 is 3D8. So let's start writing first step onwards. Nickel plus 2, 3D8. 3D8 is having 5 orbitals with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8, and 4s orbital and 4p orbital. Empty orbitals we are drawing. Now in second step, when the ligand water approaches the nickel, we have to check the strength of the ligand. Water is a weak ligand, so that there is no change in the first and second step. Same like first step, 1, 2, 3, 4, 5, 6, 7, 8. No change. 4s and 4p. No change. Now you have to check the coordination number. Coordination number is 4. So we need 4 empty orbital. 1, 2, 3, 4. Already 4 are there. Just join. sp3. sp3 hybridization. Now the last step, we are just drawing the orbitals separately and the hybridized orbitals together. So the 3D orbital, the 5 orbitals as it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, correct. The same only we just repeated. And sp3 hybridized orbital, the 4 orbitals together we are drawing like this. There is no orbital which are unhybridized. In the previous example, we got the last orbital which is not participating, which is unhybridized. But in this case, there is no box remains. So it is sp3. So now the sp3 hybridized orbitals are filling with 2 electrons. Why? Because each water is sharing 2 electrons with the nickel. So that 4 coordinate bonds are formed between nickel and water. So the hybridization is sp3. Since it is sp3, the geometry is tetrahedral. And the magnetic behavior, you see, there are 2 unpaired electrons. So it is paramagnetic. And the type of complex, no need to mention. So this is how we can understand the geometry, hybridization, magnetic behavior. So the points to remember, like first you write the oxidation state, then you lose the electron, then you write the electronic configuration in the excited state, draw orbital diagram, identify the strength of ligand, do pairing if it is required, and then you check the coordination number, count how many hybrid orbitals are needed, and then join and write the name of the hybridization, and those hybrid orbitals are filled with the paired electron. Each paired electrons are coming from the ligand. So this is how the coordinate bonds are formed between central metal atom and ligand. So the complexes are being formed. So this is the theory which is given by this valence bond theory. So you have to study and do more questions which are there in your NCERT textbook. Thank you all.